This lesson is going to cover our first section in the equations unit. So we're just talking about solving equations today. Hopefully a lot of this will be reviewed for you. The first concept is distributive property. And it says here there are two methods. So I'm going to show you two different ways to solve problems that look like distributive problems. The first one I'm going to do is going to be just your typical distribution problem. So you know how to distribute, and so you distribute that across. You get negative 30x plus 148 plus 48 equal to 168. We're going to subtract from both sides. And when we do that, we get 120. We divide by negative 30, and we get x equals negative 4. That's all you have to do. And you, I think, are familiar with that distribution property. However, the other problem I want to do it a different way. Because here's the deal. You don't always have to distribute. If it's an easy division, don't distribute if dividing is easy. In other words, you don't actually have to do the distribution. There's a different way to do it. If I look at number 2, I know that I can just divide by 2 on both sides, and those 2's are going to cancel. So now I have 8y minus 6. And now I just have to solve the equation like I normally would. So I get 7 is equal to y. So if you can see that that's an easy division problem, you can do that instead of dividing. Sometimes it doesn't go in evenly. On this one, actually, 168, you can divide 168 divided by 6, and you get an even number. I just don't know what that is off the top of my head. So I didn't do it because, 1, I wanted to show you both ways, but 2, I couldn't do that in my head. This one I know how to do in my head, and that makes it a little bit easier. So that's the first thing to know, is you don't always have to distribute. The next concept is combining like terms. As we look at numbers 3 and 4, there's a little bit of a difference between number 3 and number 4. Number 3 has like terms on the same side of the equal sign. Number 4 has, there's an n and a negative 2n, but they're on different sides. So here, what I want to do, if they're on the same side, I do want to combine them. So I'm going to combine that to give me a negative 5a. And now I'm just going to solve it. And I work out this problem, and I get a equals 1. So if it's on the same side as each other, you want to combine them. If they are on different sides of the equal sign, you treat it differently. And so on this one, there's a variety of things that you can add, subtract to the other side. I think I'll start with my 1, just to move that over. So I get n equals 6 minus 2n. Now is when I'm going to start moving my n's around, so I can add my 2n to both sides. So I get 3n equals 6. I divide by 3, and I get n equals 2. The main point on this unit, this concept, is if they're on the same side of the equal sign, you combine them. If they're on separate sides of the equal sign, you just kind of solve it, you move things around, okay? Concept 3 is on denominators, basically fractions. If you have a fraction in a problem, what should you do about it? Well, in this case, the main thing that you want to do to get rid of the denominator, or to get rid of a fraction, to get rid of the denominator, is multiply by the denominator to get rid of fractions. So as I look at number 5, I've got a denominator of 5. I want to get rid of that 5. So the way I'm going to get rid of that 5 is I'm going to multiply both sides by 5 over 1. And so on the left-hand side, that 5 and that 5 are going to cancel with each other. I'm just left with a 16. On this side, I do have to distribute this. So I get a negative 5x, And then these 5s are going to cancel, which leaves me with a minus 3x. So I just multiply by that denominator over 1, and that gets rid of the fractions. Now I have a combining like terms. They're on the same side, so I want to combine those. Oops. Just divide by negative 8, and so I get negative 2 is equal to x. Similar deal on number 6, it just looks a little bit different. So if you look at these fractions were kind of like skinny fractions. This one's a little bit longer, a little bit wider, but we're going to use the same method, and that is to multiply by the denominator. So I have a denominator of 2. I'm going to multiply times 2 over 1 on both sides. That's going to give me 18 over here. And the 2's cancel here. So those 2's cancel and leave me with a negative 1 plus n. Now I just have to solve that, and I get n equals 19. That's how you get rid of denominators. Multiply by the denominator. This last concept is the unusual situations. When we might have a no solution, an infinite solutions, that kind of thing. The first one, though, I'm just going to start working this out like I would work out a normal problem. I'm going to distribute this, so I get negative 21 plus 7n equals negative 42n minus 21. I need to solve this, so first thing I see is I'm going to add 21 to both sides. Now at this point, some people think this starts to look a little strange. It is looking a little strange. Remember, when we solve equations, we have to gather all the variables to one side. Right now they're on different sides. I need to move this 7n. And so I get 0 equals negative 49n. It's okay. Nothing's wrong with what we've done. This is still a valid problem. Next thing is I'm going to divide by negative 49. And when I take 0, divide by negative 49, that's still 0. Not undefined, it's 0. So my answer comes out to be n equals 0. Some people don't think that's a valid answer. It is. There's nothing wrong with that. That's okay. You can have an n equals 0. So that is the answer. That's going to be something that is worth putting in our margin, because some people really have a hard time realizing that. But x equals 0 is an okay answer. So don't let x equals 0 make you panic. It's nothing to worry about. It works. Let's take a look at number 8. Number 8, once again, I'm going to distribute. I get 7x plus 7 equals 5 plus 7x. I need to gather my variables on the same side. So I'm going to subtract my 7x. And something strange happened. 7 does not equal 5. However, I did it all mathematically correctly. That is the way to do it. The problem is, this is not true. And so since it's not true, what I write down in the answer blank is I say no solution. Let's remember what your answer means. The answer means that's the number you can plug back into the original, and when you work it out, it would give you the right answer. So up above here, if I plugged in a 19, then I would get negative 1 plus 19, that's 18. 18 divided by 2 is 9. That's the right answer. On number 7, if I plugged in a 0, I would get negative 21 plus 0 is equal to negative 7 times 0 plus 3. So I have a negative 21 equals negative 7 times 3. That's the right answer. 0 is the right answer. On this problem, what we're saying is there is no number that you could ever find that you could plug in to make this work. There's something wrong with this problem. There's no number that works for it. That's no solution. Let's take a look at number 9. Again, I'm just going to start out working it the normal way. Oh gosh, it looks strange, doesn't it? 2y minus 2y, that's just 0. What this means is infinite solutions. What this means is you could plug in any number in the whole world and it would work. If I plugged in a 5, 10 minus 10 is 0. If I plugged in a negative 8, that would be negative 16 plus 16 is 0. If I plugged in a 1/2, you could plug anything in, anything would work. There are infinite number of solutions. Another way to say that, some people say all real numbers. That's another good way to say it. That might be a better way than saying infinite solutions, is all real numbers. And there's actually an abbreviation for all real numbers. Hang on a second. It is kind of like the paragraph symbol, but it's with an R, and it's facing forward. So anyway, that means all real numbers. Let's look at our next example, and then we'll do some summary here in the margin and at the end. So our next example is we're going to multiply this out, negative 8n plus 20, negative 8n minus 20. Hopefully, as I was saying that out loud, you could hear that there's something strange going on. Negative 8n plus 20 is equal to negative 8n minus 20. Not sure about that. So I'm going to add my 8n, and I get 20 equals negative 20. That is not true. 20 does not equal negative 20, so again, this is no solution. Over in the margin, we started to write a couple things. We said x equals 0 is an okay answer. That's true. We might also say that if you end up with a false solution, that means no solution. Let's say like a false statement. If you end up with something that's completely false at the end, that means no solution. And then finally, what we learned in this section is that if we come up with a number is equal to itself, if you come up with the same number equal to itself, that means infinite solutions or all real numbers. We need to write some stuff in our summary. Some of these things, a lot of times a summary is really just going back to the margins and saying what the important stuff we wrote in the margins. But one thing that we should remember from the summary was the very first thing we talked about, which is that sometimes you can divide rather than distributing. Divide rather than. So sometimes you can divide rather than distributing. And then you might want to maybe restate some of these things, that x equals 0 is okay. And then you might write something about the false statement means no solutions. For instance, you could say 5 equals 0, for example, means no solution. But if you have something like 5 equals 5, that means infinite solutions. Okay, we will work on some of these in class tomorrow.